Hi there, welcome to this tutorial on Quicksort. This is part of a series of tutorials on various sorting algorithms, and this is the fourth one in this series on Quicksort. We have done selection sort, insertion sort, bubble sort, and now we will look into Quicksort. Quicksort is a little complicated sorting algorithm, but it's very efficient, and the Quicksort is based on an algorithm technique called divide and conquer. So basically what the divide and conquer strategy does is you divide a problem into two subproblems and solve each of the subproblems individually, and then see how you can combine the result of those two subproblems into the solution for the problem. So that's a quick few word summary of divide and conquer. Divide and conquer is the algorithmic technique which is used in a lot of algorithms, and Quicksort is one of them. And for Quicksort, the way we do is we pick up an element in the array. So let's pick up some element in the array as a pivot. So for example, in the visualization that we do here, we will pick up the first element in the array as the pivot. So what we would do is find the first element in the array here is 65. So we will find a way of putting 65 into a place so that all elements to the left of 65 are smaller than 65, and all elements to the right of 65 are greater than 65. So what we would do is, now the entire array is unsorted. So what we would do is we would fit 65 into the right position in the array. So where should 65 be? 65 should be in the position where all the elements on the left should be smaller than that, and all elements on the right should be greater than that. Once we do that, then we know 65 is in the right position. Once 65 is into the right position, we would individually sort the left side of 65, the array to the left of 65, and the array to the right of 65. If this sounds complicated, don't worry, let's visualize it and see what happens. So the first thing that we want to do in Quicksort is fit the pivot element. The pivot element here we are choosing is the first element of the array, which is 65. We want to fit 65 into such a place that all the elements to the left of 65 are smaller and all the elements on the right of 65 are greater. So the way it's done is using a simple technique. What we would start with is two variables, I and j. Since 65 is the pivot, I would start I with the next element of 65, I mean the element after 65, which is 87, and I would have j, which is the last element in the array. So I is now pointing to 87, which is the first element, or which is, because we are picking the first element of the array as the pivot, we would take the next one, that's 87 as the 87 as the element which I is pointing to. So I actually has a value 2, which is the index of the array. I'm assuming the index starts from 1 and not 0 based. Keep it simple in this. So this is the index of I, the value of I is 2, and the value of j is 6, which is the last, which is the size of the array. So what we would do is, now we compare 65 with the element at I. So 65 is compared with the element of I. 65 is less than 67. So that's an element which should usually be on the right side. So what we would do is we would try and find an element of which is smaller than 65 and swap with 87. So I is left at 2. So we have an element which is greater than 65 identified. So we are now looking for an element which is smaller than 65. So 80 is greater than 65, so we wouldn't want to swap with it. So j is shifted left. So 43 is smaller than 65. So what we would do is now swap the elements at I and j. So 43 and 87 are swapped, and I is incremented and j is decremented. And now 65 is compared with the element at I, which is 10. So 65 and 10 are compared. So 65 is greater than 10, so you don't need to do anything. It's already in the right thing, I mean in the right order, so I would be incremented. And 65 and 43 would be compared now. So 43 is we are using it for the right side, so it's not in the right order. So I is incremented, and 65 is now compared with 87. So what happens is 65 they are in the right order, so now 65 is swapped with 43. So now you would see that in the array all the elements on the left of 65 are smaller than 65. You would see 43, 43 and 10. These are smaller than 65, and all the elements on the right are greater than 65. So now the problem reduces to sorting this array and this array. Once these sub arrays, these three elements 44, 44, 10 are sorted, and another sub array 87 and 80, these are sorted, the problem is solved. So we actually now split the entire problem of sorting 6 arrays, I mean an element of length, an array of length 6, into 2 sub problems of small array of 3 elements and an array of 2 elements. So this is how the quicksort works. And we would now use quicksort itself to sort this 3 element array and the 2 element array. So let's see how it's done. So now we are sorting the first 3 elements. So the pivot is 43, 43, nothing happens, and j is 10, so 10 and 43 are swapped. Next 10 and 43 are again swapped, and that's your sorted array. And next 87 and 80 is the other side of the array. So these two are compared, and you would see that they are swapped. So you'd see that the entire array is now sorted, and that's the end of the quicksort algorithm. So you'd see that in this example, which was a simple illustration of the quicksort, what we do is in each like we pick a pivot and we divide the array in such a way that all the elements to the left of the pivot are smaller than that, and all the elements on the right are greater. So that means the pivot element is in the right place. So we now subdivide the problem into sorting the 2 smaller arrays, the elements to the left of the pivot and the elements to the right of the pivot. And this is how the quicksort algorithm works. Quicksort algorithm is proved to be very efficient algorithm. It's much better than bubble sort or insertion sort or selection sort in most of the scenarios. So that's a quick look at the quicksort algorithm. Until next time, bye.
If you like this video, show it by clicking like or commenting or sharing this video. We are creating more videos on varied range of topics as we speak. Subscribe to stay updated. Thanks for watching. Until next time, bye.